All right, so here's an introduction on how to work with vectors. Now, vectors have two components to them. They have magnitude, which is just the length of the vector, and they have direction. Okay, so if this is vector u, this vector here, let's call it v, vector v is the same as vector u. You may say they're in different positions though, but they are the same length or magnitude, and they have the same direction. Okay, so think about these vectors as like pencils that can be moved around on your desk. You can slide them around and keep them equivalent. Okay. Now, if I wanted to just change the direction of vector u or v, and let's say I take the arrow off there, and now it's going the opposite direction. Vector v is negative u. It just has an opposite direction. Okay. So by just switching the arrow there, it now becomes negative. All right, another thing, if I were to take 2u, this is called a scalar, and all that means is they're going to double the magnitude of vector u. So that's vector u, and that's another vector u. That's two of them, so we have twice the length of that. So this vector here, notice it has the same direction, but it has twice the magnitude. Okay. Now, in terms of adding two different vectors that have different magnitudes and directions, let me get rid of this guy here. Now let's take a vector v. Let's say vector v is going in this direction here. Now we want to find the resultant vector if you add u and v together. Now, once again, I'm going to pick this up. This is like a little stubby pencil on your desk, and it has a length of this little guy here. Now, even though I'm going to slide it around, I can't change its direction, okay? So I'm going to pick it up, and I'm going to move, the way you add two vectors together is you go tip to tail. So here's the tip of this vector, okay? I shouldn't use arrows because that's confusing with the vectors themselves. Okay, so if you add two vectors going tip to tail, this is the tip of vector u, and this is the tail of vector v. Now I'm going to pick up this green dot, and I'm going to put it right on the tail, or the tip of the other one, and I'm going to draw down there. Okay, so I'm going to take the tip of vector u, and I'm going to take the tail of vector v, which is where that green dot was, and I just put it there. Now the resultant vector, resultant is a fancy way of saying the answer, okay? So the resultant vector is going to be in purple. So now the resultant vector is now I'm going to go tip to tail is where I put them. The answer is going to be tail to tip. So here is the tail of my original, and I'm going to go to the tip of the new one there. So this purple vector is u plus v. Now I know it seems weird because you would think that the purple vector would be the magnitude if you add the green and the red. If you add them together, it would be longer than the purple there. But that's not how it works, because keep in mind that when you have two forces coming together, sometimes the direction of one will negate the energy or the magnitude of the other. So in physics, they have their own little properties to them. But simply put, you're going to take tip to tail, you're going to put them together, and then the resultant is going to be tail to tip. So let's go A to B. Here's vector A, and here's vector B. Okay. Now the resultant vector, so notice here, we're going from, notice that the tip to tail is already put together. So the resultant vector is tail to tip, which is going to be vector F. Okay. So vector F is our resultant vector. And notice that it matters. F is going in this direction. The arrow is pointing in the upper right. Okay, so it's vector F. Okay, vector F. Now I'm going to figure out the resultant vector for k plus g. So here's k plus g. G, notice they already have them placed at tip to tail. G is going that way. Now the resultant is from tail to tip now. So notice, I'm going to do this in gold. Notice the answer is going in this direction. So actually the answer to this one here is a negative f. Okay? The answer to the left side is a positive f. So even though they have the same magnitude, which means they're going in the same, they have the same length, the direction are going in two totally different directions. The orange one is pointing the upper right, and the other one's pointing down in the lower left. So very deceptive question. That's why this guy is false. Okay. Next one here, and these diagrams are really hard to work with, so I'm going to try my best to enlarge them. Now 2v, here's vector v. I'm going to draw two of those, okay? So here's v, and here's another one. Here's another v. And the arrow's pointing to the right. It's really hard to tell that in the picture. So you can always enlarge it, the diagram, but even with my glasses off, I can see that the arrow's pointing to the right. And I'm drawing them at the bottom of the page just because it's a little bit easier to work with. And all I have to do is find an answer that looks like my resultant here. Okay, I don't have to worry about the actual coordinates, like what this is, you know, if this is going to be like the tip is going to be at 3, 8. I don't have to know the ordered pair. I just have to know what the magnitude and the direction, get a rough idea. So 2u is that rose-colored vector at the bottom. Now plus u, I'm do this in blue, plus u is right here in the upper left, and vector u is over here. So I'm going to take that vector and I'm going to pick it up like a pencil, and I'm going to move it from tip to tail. So here's vector u. There's vector u. All right. Now the resultant vector is, I'm going to do this one in orange, from tip to tail. Now it's from tail to tip. So that orange vector is my resultant vector of just the bottom two. Okay. Now, so whenever you see these questions that have 3 different vectors in there, do 2 at a time, go from left to right. What you see at the bottom of the page, that orange vector, I'm going to redraw it again over here. So that is 2v plus u. Okay. I'm redrawing it over here just because I have a cleaner slate to work with. All right. Now, let's switch to a different color, purple. So negative 2w. Negative 2w. Let's take a look at that. W is this vector here, this little guy here. So the w looks like this. 2w would be, if I stack them, twice as long. So this would be 2w. Okay. Now this is a minus 2w or a negative 2w. So all I have to do now is change the direction. So this needs to do an about face. So now it's going to pointing into the bottom there. So I'm going to take this red vector here, and I'm going to put the tail of this one. I'm going to use a green dot again. That green dot I'm going to put at the tip of that one. So tip to tail, tip to tail. So if I put the green dot on top of the green dot in the bottom of the screen, I got my red vector here. Doggone it. Okay, so this is my negative 2w. All right, so tip to tail, tail to tip. So now my resultant vector, go back to green here, is going to go, I got my tip to tail, now from tail to tip. So this is my resultant vector the whole stinking answer, and that looks like this guy here. All right, so these questions have nothing to do with numbers. It has to do with geometry and kind of visualizing it. The main thing is the tip to tail thing and just kind of piecing it together. Once again, like matrices, I'm trying to give you guys a different perspective on some applications of math. If you ever take physics in college or you've taken them now, this is going to show up a lot. So hopefully you can thank me one day. If not, you can thank me now for just making your brain grow. Love you. Take care. Bye.